So we're here at the Coventry landfill. We're going to talk about leachate and leachate treatment today. An emerging contaminant that's become very big news in the industry is PFAS. PFAS is per and polyfluoroalkyl substances, which are chemicals that we have used historically since early 1950 for stain resistance, waterproofing, coatings on paper to make things non-stick, and other different applications. A lot of it in the consumer industry, some in the industrial industries. It's something that's very prevalent. Landfills do not make PFAS. They don't actually produce it. It's just what is on the products that come to the end of life in the landfill. So we've studied where it's coming into the landfill, and more than 95% of the materials that we take in this facility particularly, and in general across the industry, contain PFAS in some form or fashion. A landfill is a lined landfill, which we call subtitled the landfill, and they're designed and required by states and federal agencies to be lined to prevent water from going out from the bottom of the landfill and contaminating the environment.
As you see from the picture back here, these liner systems are multiple layers of geosynthetics and soil and stone and piping, and the whole goal is, and the whole engineering design is, that any water that comes in contact with waste comes down to the bottom, doesn't go out into the environment. It gets collected so we can send it for treatment. And so think of it as like a giant bathtub without a drain on the bottom. And we fill the bathtub with trash, and any of the water that comes down in, we have pumps that go to the bottom that pull it out. And there's a primary liner system, which is the first line of defense, which is what collects all of our wastewater, our leachate. And then there's a secondary liner system as a fail-safe underneath. So everything we do is redundant. Everything we do has a secondary source of safety. And even under that, there's another 6 feet of material that's specifically designed, that's very what they call low permeability soil, so the water can't transfer through it fast.
So most of the PFAS actually stays in the landfill, a large majority. So the landfill is actually good at sequestering PFAS. The small amount that comes out in the leachate, we want to remove because wastewater facilities can't actively remove it, or they're not designed to. They can remove small portions, but they're not designed to remove it. And so this is targeted at that, and this is something called foam fractionation. The way foam fractionation works is it uses what we like about PFAS against itself. So because of the way these compounds are constructed, the carbon-fluorine bond makes them really strong, but also the way they're actually constructed makes them like to hang out at something called the air and water interface. So basically, if you think of when you're blowing bubbles in milk, the bubbles stay right on the surface, right? So if we bubble leachate, the PFAS that we're looking for actually will come up into those bubbles, out of the water into those bubbles. And you can see the bubbles here. We can scoop the bubbles right off, and that's where the leftover PFAS is.
You can be as effective as 99% removal of our targeted compounds, 99+%. The majority of the compounds we get greater than 90% removal. And they're really looking at the ones that are targeted as concern for health in the environment.
So the way this system is designed is with containment. So primary containment is actually the pipe like this here, but everything that goes outside the building, you can see here there's actually 2 pipes. There's the carrier pipe, and there's a secondary pipe that's around it as a secondary containment. And that's by requirement that we have to have containment on everything that goes outside the landfill footprint. And so when it comes to this facility, this building itself is also containment. There's floor drains. In addition, we have passive containment, meaning that all these floor drains go to a big tank, 20,000 gallon tank. So the leachate comes through containment into this, and then it goes into a big storage tank where it waits to be treated. Once it's treated, it comes from the back end, it comes back here, and it goes back into our leachate system, where we actually collect it in another tank, load it onto a tanker truck, and send it to a wastewater treatment plant so it can be properly treated for the rest of the compounds. So this is the inside of our PFAS treatment system. These are what we call our primary fractionators, and they're big giant tanks, right, that we fill them up, and we're bubbling the leachate using venturis. We're adding air to the leachate, creating foam. This one here, you can see a little bit of foam residual on it. And in that process that lasts 30 to 40 minutes in these systems, we have 4 primary fractionators. You can see 1, 2, 3, and the other one's right here behind this. that's where the raw leachate goes in. And the raw leachate basically is what's coming right out of the landfill. We send it through just a filter to get any large particles of dirt or anything else out so that it doesn't mess up our fractionation process. And then we fill each of these. You can see here the green. These are level indicators that show us what the level of the water, the leachate is in here. So this system right now is in the fractionation process. It's full of leachate. And we're just pumping that leachate in this tank. We fill it. We just start pumping the leachate around through something called venturis right here. These are venturis that actually inject air, little air bubbles, into that leachate, and you can see that it creates that foam, right? So that foam goes out into a tank. This, when the process is done, goes as treated leachate. The foam doesn't finish there. The foam comes over to the next step in the process, goes into our primary foamate tank, or here, and that's called our primary foamate. That collapses back down into a liquid. We want to narrow that down to a smaller amount of liquid because we want to take that PFAS and shove it into a small amount of liquid. And so these secondary units kind of do the same thing. They're a little bit different shape, different size. All they're targeted to do is to take that foam that we've made over there and consolidate it into a smaller fraction. And so you can see, right, this is a great example. Right now you can see it foaming. And so the PFAS is coming up in that foam, and this primary concentrate is getting less and less PFAS.
We've processed 22.5 million gallons, almost 23 million gallons of leachate. So we've been able to take the PFAS out of it. So we're measuring success by the fact that that leachate is now much cleaner, much less PFAS going into the environment, and we're actually able to take that and put it back in the landfill to stay forever.
There's no other treatment that goes on in this building except for PFAS. That is all we're looking to do is to remove it.
Treating what comes out of the back end of the landfill so that it's more environmentally friendly or better for the environment was something that was kind of a no-brainer. It's expensive. You know, it was an expensive project, and it costs money to operate, and it's something that Casella as a whole is committed to doing.